Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today in this lecture, we will explore the concept of magnet. We will know that what does mean by magnetic field, what is magnetic field lines, and what are the properties associated with a magnet. So let's start the lecture with simulation. Here we have the permanent magnet. The right side of the this magnet is labeled as north, and the left side is south. So around a magnet, there will be some region in three dimension from a magnet in which the effect of this magnet will be present. Mean that if we bring the other test magnet into that region, the test magnet will feel some force due to this permanent magnet. So that region around this permanent magnet in which the effect of this permanent magnet is present, that region is called the magnetic field. That region is actually represented by these lines. So here these lines is nothing but this is actually the effect of magnet. So here around this permanent magnet there will be the combination of large number of points up to the region in which its effect can be felt. Mean that the magnetic field is consists of large number of points. So at each point the magnet will have their own effect. So here at this point the magnet have this effect because here this is the test magnet, the right side is the north and the left side is the south. So here in this case the north of the source magnet will attract the south pole of this test magnet, due to which this sort of effect will be occur here. So in this case, this north will attract this south in this direction, and here in this case here is the south, so the south will attract the north, and in this way at each point around this permanent magnet will be having some effect from the source charge. So here at each and every point, if I take the test magnet, that test magnet will feel some force due to this source magnet. So the force, the magnitude and direction of the force exert on each and every point around this permanent magnet will be labeled by the lines. So that lines around this permanent magnet is called the magnetic field lines. Magnetic field lines are the virtual lines, are the hypothetical lines which represent the strength and the direction of the source magnet at each and every point up to the region in which the effect of this permanent magnet is present. So this was about the magnet and the difference between the permanent magnet and the source magnet. Source magnet having the magnitude of magnetic field is very small or negligible as compared to this. So the test magnet have the magnitude is negligible as compared to the source magnet. So here up to here we know about what does mean by the test magnet, what is the source magnet, what is magnetic field, and what is magnetic field lines. In this simulation we will see that if we take the magnet to here at this position, so the force of attraction will be present between this north and the south. So I'm going to this magnet here. This magnet will be attracted toward this magnet, and the force on this magnet at this position is low, and their force will be increased. So here, due to which the motion of this magnet is increased. So if this magnet come near toward this magnet, the motion of this magnet will be increased. So let's observe it here. Their motion is increasing, and it has increased. So this is because the magnetic field intensity at this position will be different as compared to this position and as compared to this position, and that is increasing. So due to which the force on this magnet is increasing as a function of the distance between the two magnet, and due to which this the motion of this magnet is increasing. A magnet is an object which attract the other magnet or other ferromagnetic material. So on the basis of magnetic field, the materials are divided into magnetic material. The magnetic materials such as ferromagnetic materials, including the iron, cobalt, and nickel, will be attracted toward the permanent magnet. It means that if we bring the iron towards near to the permanent magnet, the force of attraction will be present between the iron and this permanent magnet, and therefore we characterize that in the magnetic material, and we call them as a ferromagnetic material. On the other hand, we have the aluminum and the copper. Aluminum will have, if we bring aluminum near to this permanent magnet, there will be force of attraction, but the magnitude of the force of attraction between this material and this permanent magnet will be less as compared to ferromagnetic material. Here, if we bring the copper near toward this magnet, this permanent magnet, the force of there will be the force of repulsion between this permanent magnet and this copper. So the force of repulsion will be very less in magnitude. So this paramagnetic materials are the material in which there is a force of attraction, but that force of attraction will be less in magnitude as compared to ferromagnetic materials. And the diamagnetic materials include the copper, which on which the force of repulsion will be act due to this permanent magnet, and that force of repulsion will be less in magnitude. So this was the arrangement of materials and the basis of the magnetic properties. So what is the phenomenon occur inside the ferromagnetic material due to which the force of attraction and these material from the permanent magnet is more? So let's consider we have the iron strip. So here the ferromagnetic material iron strip, and this we know that the iron strip will consist of the large number of the iron atoms, and each iron atoms will have the electrons, and we know that the electrons in the orbital are present in opposite spin. So it means that inside the orbital we have the two electrons, and they two electrons in the orbital are present in opposite spin. Mean that when one electron is moving anti-clockwise direction, the other will be in clockwise direction. So this electron, due to spinning, produce the magnetic field. So here, this, let's say this side will be north and this side will be south, and this the other electron is moving in opposite spin. So here this side becomes south and this side become north. Now, in this case, in orbital, the electrons are in opposite spin. And so here, these electrons even have the negative charges, but they will do not repel each other because of the magnetic field, and that magnetic field is originating due to the spin of the electrons. So here, due to the spin, this north and this south will attract each other. This south and this north will attract each other, and the two same charge electrons in the orbital will be present. Okay. So what we are going to say is that now let's say we have this iron rod, and inside the iron rod there will be large number of the iron atoms, and each iron atoms will there will be large number of electrons, and that electron will be present in the orbital, and inside the orbital the electrons will be present in opposite spin. So due to the spinning of the electrons, mean when the charge body, the electron is actually a charge body. When the charge body is in motion, it will produce the magnetic field. So inside the orbital, the electrons are in motion, due to which the magnetic field will be produced. So if large number, so the atom is a whole, and the atom there will be one north and the other side will be the south, and if there are large number of atoms combines, and atoms and molecules are combined, it form a group, and in that group the alignment of electron will be the same, mean that their magnetic field will be added up. So that group will make a region, and that region is called the domain. So domain is actually the region in which the all molecule will have the same alignment of electrons. So this region is called the domain. So inside this iron rod there are large number of domains. So here the each portion represent the domain. So there are large number of domain inside the iron rod, and each domain will have their own direction of the alignment of electrons. So that alignment of electrons will have the magnetic field. So here this was the alignment of the electron was in random direction. So this was in random direction. If we put this magnetic strip in the magnetic field, the alignment of electron will be in proper direction. So here it align from the north pole toward the south pole. This phenomenon occur inside the iron metal, due to which the iron will have the magnetic properties. The magnetic properties of the iron, cobalt, nickel, and other ferromagnetic material is due to the alignment of electron in the same direction. So this was about the ferromagnetic material. Now we will know that how a permanent magnet is made. So in order to make the permanent magnet, we will take the same ferromagnetic material. Let's say we will take the iron rod, and we will molten that iron rod. We will give more energy, and will take the molten form of the iron. So here we have the molten form of the iron, and we will put that molten form of the iron in the magnetic field. So here we have the what we can say, we have the solenoid, and inside the solenoid we have the magnetic field. We will discuss this in later videos. So the solenoid is such like shape in which inside the solenoid there is a magnetic field. So when we put the molten iron inside this solenoid, the magnetic field lines will pass through this molten iron. So the electrons of the iron in this case, due to heat, is in excited state. So that electron will align themselves with the external magnetic field, and that electron will align in that position with the external, will align themselves with the external magnetic field, and due to which it show their ferromagnetic behavior. In the same time, we are cooling this molten state of the iron. So we are decreasing the temperature of this molten iron, and this will be solidified. So during the solidification of the molten iron, we provided the external magnetic field. So the electrons of this molten iron will remain in their uh, own direction. So if this become a solid, then it will form the permanent magnet, and the electrons will be aligned in a specific direction, and due to which we call them a permanent magnet. So the permanent magnet is actually made from the ferromagnetic material if we pass them through a specific process. So this was about the formation of the permanent magnet. Now we will explore the other properties associated with a magnet. So here, if we consider the horseshoe magnet, so there is a difference between the permanent magnet and a horseshoe magnet. This magnet is called the horseshoe magnet, and this shape of the magnet is called the permanent magnet. So let's take the horseshoe magnet, and if we bring that near to the nail will attract it toward this permanent magnet. But when the nail is touched with this permanent magnet, the domains inside the nail will be aligned, the electrons will be aligned in a specific direction, due to which the nail will also behave as a magnet. So if the other nail touch the this original nail, okay, if the other nail touch this original nail, the other nail will also be attracted. Even the other nail is not directly connected with this magnet, but that is actually connected with the other nail, and in this case it will be attracted. It means that here in the first nail, so in this nail, the electrons are aligned in a specific direction due to this original magnet, and due to which this nail will also behave as a magnet, and it will attract the other nail. And this properties of the magnet is called the inductive properties. So this properties of the magnet is called the inductive properties, and this is actually the directive properties of a magnet. If we hang off the magnet, here is in mention, the north of this magnet will be align themselves to the south of the geographic magnet of the earth, and this south will be attracted toward the north of the magnetic field of the earth. So as we know that the earth have their own magnetic field, which called the geographic north and south. In this way we can determine the direction of the earth magnet, just like we use the compass. Okay, so this properties of the magnet is called directive properties. We can determine the direction of magnetic field due to a test magnetic field. Um, and now we have discussed the attractive properties of the magnet in the start of this video, and the last part of this video is actually related to the magnetic pole exist in pair. It means that when so let's say if we have the charge, okay, we have the positive charge. This positive charge can exist without the negative charge, okay, but the if we have the north pole, this north pole do not exist without the south pole. So if there is a south pole, there must be the north pole. If there is a north pole, there must be the south pole. Mean that single south pole will not exist. So the reason behind this is that if we take this permanent magnet and make their pieces and make their small pieces, let's say this times small pieces. So in this case, this side will be the north and this side will be the south. And if we bring it towards the molecular level, so the molecule will have one side is north and the other side is south. And if we going toward the atomic level and inside the atomic level into the orbital, so the orbital also have electrons in opposite spin. So due to the spinning of electrons, okay, due to the spinning of electron, there will be magnetic field. So one side is north and the other side is the south around around this around the spinning electron. We call them a spin quantum number. So here in this basic level, the still the magnet is the poles of the magnet is present in pair. It means that if the small and the small portion of the magnet, there must be north and south pole. The north pole without south pole will not exist. So if there is a south pole, there must be the north pole. And if there is a north pole, there must be the south pole. So this was the brief introduction about the magnetic field lines and properties of a magnet. So here, this is some simple example. We have the hydrogen atom, and similarly we have the other hydrogen atom. One hydrogen atom have the electron, outermost shell electron, and this have the unpaired electron. And due to covalent bond, they share their both electron, and in this case these two electrons will be present in the s orbital. So because these same charge electron will repel each other, then how they exist in the same region here in the orbital? So the existence of this is because of the opposite spinning. So one will be spin, let's say one will be a spin in clockwise, the other will be in anti clockwise direction. If one is spinning in clockwise direction, so here in this case, and let's say in this case, this side will be the south and this side will be the north. And in this case, because the direction is in opposite, so here this will become south and this will become north. And this north and south will attract each other. This south and north will attract each other. And due to the attraction between the magnetic, due to the magnetic field, these electrons will exist in a same region. So this was the brief explanation about the topics mentioned here. So that's it, guys. Thanks for watching.